JEE MAIN 2026, 2nd April Shift-2, Physics Section A, Question 36. Let's visualize the problem. A spherical ball of mass 2 kilograms is dropped from a height of 10 meters above a sand pit. It hits the sand surface with some velocity v, then penetrates 10 centimeters into the sand before coming to rest. We need to find the average force exerted by the sand on the ball. The question states, a spherical ball of mass 2 kilograms falls from a height of 10 meters and is brought to rest after penetrating 10 centimeters into sand. The average force exerted by sand on the ball is blank newtons. Take G equals 10 meters per second squared. The options are A, 1980, B, 2020, C, 2000 and D, 1000. The key concept here is the work energy theorem. When the ball falls from height h, its potential energy converts to kinetic energy at the sand surface. Then, as the ball penetrates the sand, the net upward force, which is the sand force minus gravity, does work to stop the ball. The work done by the net force equals the change in kinetic energy. So, F sand minus mg times the penetration depth d equals the kinetic energy at the surface, which is half mv squared. Step 1. Find the velocity and kinetic energy when the ball hits the sand. Using v squared equals to gh, we get v squared equals to times 10 times 10, which is 200. So v equals root 200 meters per second. The kinetic energy at the sand surface is half mv squared, which is half times 2 times 200, giving us 200 joules. Step 2. Apply the work energy theorem. The ball decelerates inside the sand over a distance d equals 0.1 meters. The net upward force is F sand minus mg. Since mg equals to times 10 equals 20 newtons, the work energy equation becomes F sand minus 20 times 0.1 equals 200 joules. Step 3. Solving for F sand. From the equation, F sand minus 20 times 0.1 equals 200. Dividing both sides by 0.1, F sand minus 20 equals 2000. Therefore, F sand equals 2000 plus 20, which gives us 2020 newtons. The average force exerted by sand on the ball is 2020 newtons. The correct answer is option B. Here are some exam tips. Remember these shortcuts for work energy problems. For free fall, V equals root 2 gh. The kinetic energy at the bottom equals mgh. And always apply the work energy theorem as net force times distance equals change in kinetic energy. A common mistake is forgetting to include gravity when finding the sand force. The net stopping force is F sand minus mg, not just F sand. So always add mg back to get the actual sand force. Like and